My name is John Roner. I am the Chief Engineer at Intelligentry, and I am the patent holder for the plasmic transition technology and the control of this engine, which is a very far derivative of what was originally the tap engine. What we've learned is a lot more from what they know. Okay, the subject of this particular video is what's going on here, because we've got a brand new, what in the scientific world we call anomaly. God, you got me up too early this morning, you know that. I was going to sleep until about 8:30.
Yeah, I called him at 7. Sorry about that.
I know. Anyway, this particular device that you see here is a system that we use to check how good a reaction we can get from a specific gas mixture in the chamber. And what you've got here is a special plastic see-through tube made out of a very high temperature Lexan type of plastic. And inside there you've got a piston which is made out of another high temperature, high strength plastic, and a normal head here. And this is a normal system, except that there's a spring here just to bring it back. Now on this end, and you can just see it right down in there, there's a balloon on an orifice that comes in. And what we do is we fill this chamber with fuel, the fuel we're going to use or want to test, and we actually overfill it into that balloon so that we know we've got everything done right. And then this is a standard actuation system, and this coil is the standard exciter coil that we use for the transition chamber. And what happens is we push a button, this excites that one time, and we measure how far this piston moves down. In a normal situation, this coil here would be right here. Okay? Well, this has worked for us to gain an awful lot of information on an awful lot of different gases mixtures, and it also gives us, we also test different ratios that we are using in the coil for the exciter coil. So, and it gives us all kinds of information about how this turns ratio works, how that turns ratio works, what this gas mixture with this in it and this proportion works, etc. And so we've collected a lot of data from this particular device. However, one time after we were just playing around, we decided to try a coil in here which was actually wound to basically what PAP says in this patent is supposed to be the coil, which by the way we've never used and we don't use. So this coil is basically the same as the PAP coil. Okay, we put it on here, we stuck it in here, we wanted to see what would the old PAP coil do, just for the hell of it. Now, you know, months and months of training, and this is the first time we decided, hey, it might be fun to see what he did, right? But when we put this on here, and we filled it up, and we fired it, the piston didn't do its normal pop. It just did a little and quit. And so I looked at it and said, well, damn, I got 24 volts at 2 amps on this thing. You know, there should be plenty magnetics on there. But it only went, right? I mean, it only moved about that far. Well, so we thought, damn, there's something weird here. And so a friend of mine who's another engineer that worked with me on this reached in to move the coil to see if there was something happening here. And he reached in and grabbed the coil like this and went, holy shit, pulled his hand back out. The coil was dead hot. Okay, we found out later on at 208 degrees. Okay, so then we reached down and we moved this coil from here back over here. Now, this is basically a bed spring that's used just to home the piston, right? Well, what's interesting is we put the coil over here and the damn thing got hotter. right? Well, and the other interesting thing is it stayed hot until it sucked the balloon back inside the tube, which means it created a vacuum inside, right? Well, in trying to figure this out, I actually went and grounded this coil at different times, and it does the same thing. We finally went out and got one of those heat guns so we could see what the hell was going on, because yeah, it was hot to the touch, but then again, okay, you know, what's that really mean? Yeah, it's hot to the touch. So it turns out that if this is down here, initially, this will run somewhere between 204 and 208 degrees. Now, if you move it back here, it moves up into the 220 range. Next thing that's interesting about this is that if you ground this coil, it stays hot. Now, those of you who understand electronics know there are only certain things that can make a coil get hot, right? And if you ground the coil, that takes most of them pretty much out of the picture. But guess what? This thing stayed hot.
When you say stayed hot, you mean as long as the balloon was releasing the gas?
As long as there's fuel in here, it will stay hot. And that can be a couple of minutes depending on how full you make the balloon. Okay, and the interesting thing is, it always goes back to a complete vacuum. It always pulls that balloon back into the hole. And you know how it is with a balloon. When it comes back down and it's got all of the ridges, okay, you know that someone stuck this thing, didn't just let it happen. Well, that balloon will actually get totally sucked out. Okay? And quite honestly, if you fill it up this big, it lasts longer than if you fill it up this big. So we know that whatever is happening here is happening because of the fuel, right?
Which is noble gases.
Which is a noble gas mixture, yeah. One of our simpler gas mixtures. Okay, it's not the most powerful one, but it's pretty close to what the PET people had originally. Anyway, so then we decided, okay, well, let's see if there's any light. So we built a light-proof chamber over it and put a webcam in there, and guess what? No light. So in any nuclear reaction, you're going to have a side effect of light. I mean, if you look in this port right here, when this engine's running, you will see a light that happens every time the plasma happens. We couldn't, no light from there. So I took my radio frequency spectrum analyzer and I put a probe in here, and guess what? No radio frequency. And then I thought, well, hell, let's go measure the current in this thing. How much current? In a half a volt. You know, even grounded is putting up a half a volt. Why? Well, that, my friends, is the question. Okay, this thing is generating power somehow. We don't know how. And I've got a physicist that works right with me, and he's got two of his friends that are over now looking at this too. Okay, and we have now been requested to not disassemble this device until after at least several other schools send their people over to look at it. So basically we lost our piece of test equipment because in the scientific world, when something is observed, okay, other observers want to come and see it, but they want to see it just as it was done. They don't want you to take it apart, try something different, and then redo it. But, so that's basically that. Now, it is interesting because we did break the rules at one time. Way back in the beginning, when we first noticed this, we actually took this thing apart. Okay, what's interesting is this coil here normally just slides on and slides off, no problem, right? But once this thing has gone through its heat, this thing is virtually a hard fit. I mean, you have to pull on it to make it move. But the other interesting thing is, okay, that this gets hot, but the spool doesn't. And
the spool, meaning this inner
the spool is
here,
this white piece here.
Doesn't get hot.
Doesn't get hot. Nor does the cylinder. This is a plastic cylinder. At 208 degrees, you should be able to find some warpage or something. right? You got to remember, okay, that what we do here doesn't generate heat, so we can use just about anything we want in here. But
so if I understand
this
right,
is still absolutely transparent and absolutely perfect the way it's been, and nothing at all, okay, in the physical nature of this work has changed. And we did take it apart one time and then rebuild it just to see if, you know, a different coil would have a different effect. We put a different coil on there and guess what? Nothing happened. Okay, so we took that coil off, put this coil back on, and guess what? Boom, there it is again. So we know that it's some combination of what's going on here. But right now, we don't know what.
And you've replicated it many times.
Oh yeah. We've replicated it enough times to make it go haywire if we wanted to go haywire. But no, as a matter of fact, it's sitting there pretty much static now, waiting for people to come in and study it. Like I say, Peter is our nuclear physicist, and he's absolutely sure that this thing is getting energy from somewhere that nobody's even thought about yet.
Dark energy.
We don't know. You know, it's a little hard to. It's like anything else at this point, and that is that you've got to get together a group of people who are all scientists and look at it in a scientific way, and then let them have their conversations and let them figure out where it is.
So
Do I understand it? No. It doesn't fit any physics I ever studied.
If I could recap here, basically what happens, you fire the piston
Right.
in a normal test to see how far it goes against the spring and then come
Right.
back. In this case, it only went just a little bit, but as
Right.
soon, first of all, you fill the chamber with gas and the balloon comes out the back side here, fills
Right,
up.
because we overfill it.
Yeah, you overfilled and balloons out here, overfilled. And so you fire it, it only goes a little ways, but all of a sudden this coil goes up to 208 degrees and it stays there, and this balloon gradually if it's full, it goes about 2 minutes, deflates, is releasing its fuel.
The time is really a function of how much fuel is in the balloon.
How much fuel is in there, and as it goes down and then it goes into a vacuum, and at that point this stops heating.
Right.
And
Goes cool.
Drops down to normal room temperature.
Yeah.
So that's the effect that you've observed, and you've been able to rule out any normal means of heating a coil.
Oh yeah, we've actually gone so far as to take the coils off here and ground that coil over there, and it still sits here and does its thing. It's not getting any secondary activation from anything. Okay.
And in terms of the ramifications for your technology, this shows...
And by the way, we've actually taken this metal case here and put it on a hard ground. So it's not got anything to do with the case floating and creating anything either.
When you're done, is your fuel all gone?
Oh, it's all gone. It sucks the balloon back into the tube.
I mean, when you open it up, there's no more fuel inside that chamber.
Well, consider for a moment, okay, what has to happen in order for the balloon to get pulled back into the tube?
That's disappeared real soon.
It has to become a vacuum. Yeah? So it's all gone.
And then you're putting more fuel in on the next cycle?
Well, and the next time we want to test it, we actually fill it up again, and then we hook everything back up and try it again.
So,
and by the way, okay, it doesn't have anything at all to do with how much voltage we put on that coil to start with. You can put 12 volts on it at a couple amps. You can put 24 volts on it at 5 amps. You can put it doesn't seem to, as long as there's some kind of voltage on the coil to start with, okay, it doesn't work if you don't put voltage on the coil.
Have you seen any radiation or anything coming out with that?
have you tried to detect radiation?
Well, yeah, I mean, we've done it with, simple Geiger counters and stuff like that. We haven't, the thing's going to end up in a lab here in the next couple of weeks, and they're going to actually put it to the full series of much bigger tests than we can. I mean, let's face it, okay, I don't have the resources to buy the kind of stuff that they're going to subject it to. So.
Have you ever measured the frequency around the coil?
There's no frequency around the coil.
He did measure it. You did measure it.
I've got an RF spectrum analyzer that's good from 5 hertz to 50 gigahertz.
Okay.
And there's absolutely no indicator anywhere outside of the normal background. No, that's the first thing I went looking for too, because the natural reaction is, well, the thing's got to be reacting to some radio frequency or something.
Indeed.
Because that's the only way the coil will actually get hot. Okay.
Something's going on.
Right. But as it turns out, there's no answer that I can come up with in electronics or physics.
When you measured the frequency, you said you were measuring it inside a box you put it in a box for visualization, and also you put your frequency up against it. Did you ever try measuring the frequency inside the cylinder itself?
No, because you can't get there. Okay, you're thinking about inside here?
Yeah, inside the inside of the coil, basically, rather than what's on the outside.
There's no way to put a probe there. I mean, short of drilling a hole and sticking a probe in.
Right.
Okay, and that would be counterproductive for...
You'd lose your vacuum space.
Well, not only that, okay, but now you're going to run into secondary problems with, we also don't know what that first pulse is. All we know about the first pulse is it moves the piston about that far. Not the usual 5 to 1, but that one. So we don't know what's going on with that particular pulse yet. But the coil does have to be over that junction in order for it to start.
The coil has to be over here?
It has to be over the cylinder, the actual chamber.
So you fire it
This
and then
down
you
here
move
is
it?
nothing. Okay, the actual firing chamber is right here. The transition chamber is made up between this head and the top of that piston. Okay, and this has to be over that. So it has to have some type of ionization of some kind in order to get that first pop. But we don't know what that is.
Some kind of chain reaction takes off after that.
I wish I knew. Okay, the simple fact that you don't find the light. Okay, after it starts is a little bit puzzling.
What are the ramifications for plasma with this phenomenon?
I hope they figure it out. I hope they can find some use for it.
But does it vindicate the fact that there's some unusual stuff going on with the plasma? I mean, with the noble gas, and that we don't know everything about noble gas that we thought we did?
Well, you're asking me a hard question now, because we already know that there's something happening with and I will use my physicist's proper term, the pseudo-plasma. Okay, because we don't actually generate a real plasma. Okay, but we know that there's something different happening there.
And you're calling it pseudo because it doesn't maintain it. It shows up,
right.
and then you annihilate it.
And maintaining a plasma. Okay.
And that's the definition of plasma, is that it's maintained.
It's a maintained structure. Yes.
But you create it and then destroy it.
Right. Well, we create it and then let it destroy itself. In fact, just for that matter, I don't know how much of this I can get into without getting into our own patents, but we actually don't allow the plasma to complete its cycle. Okay, we actually force the plasma to stop. And that's how we control the speed of the engine.
And that phenomenon is part of creating this effect?
I wish I knew.
As a trigger?
Unfortunately, we're too far up on the front of the curve to come up with good hard answers to the questions you're asking.